I want to start this video with a quote that I just recently read, and it's that RISC-V is inevitable. So, in the next few minutes, I will try to explain why RISC-V is important. I will give you some example about some of the famous ISA and why we need a kind of generalized ISA, and then we will go to the main purpose of this video, which is compiling the Linux kernel for one of these RISC-V SoC. Yeah, let's show you my board that I'm going to present today. This is the the SPC is from the MangoPi MQ Pro, and the SoC itself is from Allwinner, D1 from Allwinner. This is the first SoC RISC-V from the Allwinner. It has one core, 1 GHz CPU, 1 GHz DDR3 RAM. It has 2 USB-Cs. It has HDMI. It has DSI. It has DVP. It has onboard Wi-Fi module as well, and the micro SD card to store the data. And we have a GPIO which is compatible. I mean, the same footprint as what we have on the Raspberry Pi. So for the debugging purposes, I will connect the debug 0 to the USB serial adapter, and then I will connect it to the PC, so you will see some debugging information as well. And I mean, you shouldn't expect too much of that because it only has a 1 GHz, 1 core CPU. I mean, if you want to see something more efficient, more powerful, I would recommend go for a i5 cores. Those are one of the best cores that I have ever seen. And yeah, I mean, we will go to the Yocto project, finding the suitable meta layer and then compile it. Okay, all we need is to add the correct metadata into the POCI that we already have in our VM machine. So we have to just search for RISC-V GitHub. Yeah, the first one. So here we have to look for the metadata, RISC-V metadata, and it is for bitbake. So all we need is to just clone this repository. Let's come back here. I mean, before that, let's look at some important things on here. So right now we are in the master branch. If we go to the conf and then go to the layers, we will see and as you can see here, this layer is compatible with MichelDor. This is one of the probably the latest version of the POCI. Let's search for the POCI or Yocto releases, the first link. So MichelDor is kind of is still in progress. So why not use? I mean, previously remember that we were used the Dunfill code name, which is the LTS. But right now, I mean, would you like to go to the Kyrgyzstan? I mean, this one is also LTS with minimum of support till April 2024. So why not going to this LTS version? Let's see if they have this version on the RISC meta layer for RISC-V. So they have Dunfill, they have Kyrgyzstan as well. So I just click the Kyrgyzstan, and as you can see, right now the layer compatibility is changed to the Kyrgyzstan, and probably some more as well. So I have to just clone this repository. But I mean, another thing is that previously we had the POCI and the branch of Dunfill. So why not going back and then cloning the Kyrgyzstan as well? So here we have the link for the download for the POCI. So just copy this one We will go to the VM machine, CD desktop, and then we have to just paste. Let's delete this branch from here. It might take a few moments. And when it's done, we have to cd Pocky. But as you remember, we didn't specify the branch, so we have to git checkout as well. Git checkout. And then it's go to the Kyrgyzstan branch. The other thing that we need is the RISC-V meta layer. Coming back here, Kyrgyzstan, copy, going to the VM. So we have to cd to the Pocky folder and then use git clone RISC-V repository, and then git checkout Kyrgyzstan cd meta dash RISC-V, and then Kyrgyzstan. Okay, we can just specify that by git status as well. Yes, we are already in the Kyrgyzstan branch. And coming back to the Pocky folder, remember this initializing the environment. And finally, you have to just hit, and then you have to just run the bitbake. But before that, you have to specify the machine as well. So which machine we have to use? If you go to the RISC-V repository, under the conf, under the machine, these are all machines that are provided from the RISC-V. And as you can see, one of them is similar to what we are going to use. I mean, Allwinner D1, this is the CPU that we are going to use, but I mean, kind of different board. Let's just search this name. As long as the CPU is the same, hopefully everything gonna work correct, except some of the IOs, which we can go through them and then fix them according to our MangoPi MQ Pro board. Same D1 SoC RISC-V from Allwinner. So we can stick to that, no problem. So what you need is to copy this name, and where you are going to call the bitbake, you have to specify this machine. You have to go to the, you might be able to go to the build and then conf, and then under the local.conf, you can specify the machine here, machine to whatever you would like, or simply you can say machine is equal to Neja board, and then bitbake. For example, we are going to use the core image minimal because we don't want to add more packages into that, and then hit the enter. It's not working. The problem is that because we didn't add the RISC-V meta layer into our BB layers. So go to the Pocky, you already saved the name, go to the build, go to the conf, BB layers, and you have to add RISC-V meta layer here. Okay, hopefully this time will work. Yeah. It's working now. So you have to be patient. It takes a while, probably because this is the first time that we are building this image. It takes a couple of hours. So be patient. So we will back here when the all compilation is done. Okay, it's done. And in the next step, we have to connect the SD card. into the PC and try to burn the image into the SD card. So I usually clear the SD card. So we have to unmount it, mount it, and then we have to delete the partition. I mean, it's a good practice to always clean the SD card before running a new image. So let's see where is our images generated. It should be under the Pocky. Oops. Pocky. Field. Temp. Deploy images. Ninja Allwinner D1, and this is all the things that we need. So we have to use a file name .vic.gz. So here the file that we are going to burn into the SD card .vic.gz, and first we have to extract it because it is compressed at gz, and then we have to burn it in using the dd command. So this is the command that we are using. gunzip-c, the image file that we are going to unzip, .vic.gz, and then we have to use the dd command to burn the output of this vic file into the SDB, which is our SD card. I will hit enter, my password, okay, I notify something. I mean, it's taken a long time and it's only burned around 4 gigabytes. I mean, there should be something wrong. I don't want to burn 14 gigabytes into my SD card. Let's see what is going on here. So let's go to the, where was that? Under the, we go to the Pocky, we go to the meta RISC-V, we go to the VIC files. This WKS file shows how the VIC file should be look like, what is the size of it, and etc. And as you can see, the rootfs is 14 gigabytes. Hell no. 512 megabyte would be okay for me. And then we have to build the bitbag one more time. Oh, before that, we have to clean the SD card. As you can see, this partition is going to be huge. We don't need this 15 gigabyte or something rootfs file. Okay. And we have to use the dd command. Yes, hit the enter, password. I mean, this time it's gonna be so fast because it's only need to copy 512 megabytes of data. It's done. So I have to eject the SD card and then put it into my SVC. And in the next step, we have to connect the USB to serial adapter. So I just downloaded this file from the MangoPi website, and it is for MangoPi MQ Pro. And if we search for GPIO, Control F, GPIO. So where is that? Okay. This is the GPIO header. As I mentioned before, it's similar to the Raspberry Pi GPIO pinout. So we have to use TX0, TX, and RX0 and ground to connect it to the USB to serial adapter. I will do that, and then and I have to open up a PuTTY terminal as well. Go to the serial. My USB to serial adapter is connected to COM5 and then 115200. Hit the enter. So here the terminal. I inserted the SD card. The serial to USB adapter is connected. I have to just power up the board using the USB-C OTG port. And yeah, everything is working fine. I mean, the beauty of this metadata and Yocto, everything just work out of the box. I mean, the base minimum is working really fine, but if you want to add some features, you have to do something about that as well. So let's say ls, and then we can use uname-a. So as you can see, it is that it is D1 Allwinner D1, and this is the kernel 5.16, and this is the preamp, and everything is running fine. So what we're gonna do next is to connect an LED to some of the GPIO and try to turn them on or turn them off. So usually there is a library named GPIO, Libgpiod, which is installed with these images, and you can access to the GPIOs. If you search for GPIO and the tab doesn't work because we didn't actually add this library into the kernel using the Yocto. So right now we can use the sysfs to turn off and on the LEDs. So to do that, we have to go to the sys. We have to go to the classes, and after classes, we have to go to the GPIO. Yes. So as you can see, we have the GPIO chip 0, and we have to export some GPIO here. So what you can do, you can use export, and then the pin number. What is the pin number here? So we will open up the MangoPi manual sheet. So this is the GPIO pin header. So pin 14 would be easier to find, okay? And it's connected to PB4. So there is a table which map this PB4 into a number or line number that is compatible with sys classes. So to do that, we have to this map function. So here, as you can see, the PB base number is 32. And here, if we are going to use PB4, we have to add 32 plus 4. And then this is the GPIO line number that we are going to use. I mean, every IO block has its own base number. So we have to use echo 36. And then we have to use export. Okay, so right now this node is actually activated for us. We have to use GPIO cd GPIO 36. Okay, we have to use ls. Okay, right now we have a couple of options. First, let's set the direction. For the direction, we have to use out, and then direction, and the GPIO set to output, and then you have to set some value. You can use 1 and then value. So let's open up my camera. You can see that what is happening here. So this is the camera. So I already set it into 1, but let's set it to 0. Coming up, hit the enter, it's turn off, turn on, turn off. I mean, it's working fine. And as you can see, these two pins are connected to my serial adapter, and this is the LED that I connected to PB4 and ground, and it's working fine. But as you can see, I mean, this method is called sysfs, and it is deprecated. Please don't use that. We have very powerful library, and its name is libgpio, and we will going to use that here. So let's power off this board and add some feature to the local conf. So we have to search for open embedded metadata or GitHub. The first one. So this is the open embedded. Let's go to the main repository. So meta open embedded. So on here we have to go to the meta open embedded OE, and then which one? Recipe support. Let's see if it is here. Libgpiod. Yeah, I mean it's here. So we need this repository. So as you can see, we couldn't actually, I mean, we have to go to the main repository to be able to download it. Let's see, change this one to the Kyrgyzstan as well. Here, I mean, just in fact, just in a case to see if it is there. Okay, we just clone this one, come back, cd into the main Pocky, and then git clone the repository name. Let's specify the branch here this time, -b Kyrgyzstan. It is done. Let's run the feedback one more time. When you have this kind of weird, oh, okay, the problem is that we added the meta layer, but we didn't add it into the local conf. Let's go to the Pocky. Here, open embedded, and then we need OE properties. Just I want to see the name, local conf, BB layer, and here we have to add the open embedded. Save it and cross my finger. This time it should work. Okay, it's done. I have to connect my SD card to the PC, virtual machine, and then we have to clean it up, and then connect it to my port. Open up the PuTTY terminal and power it on. Okay, root. So let's see if the GPIO library is installed. Yeah, the GPIO set, GPIO get. I mean, these are the GPIO tools. If you remember previously, I talked about the local conf. These GPIO tools, these are the tools that are provided for you. Otherwise, if you just install the libgpiod, I mean the libgpiod shared object would be provided for you, so you can access it using the other programming language as well. So remember this one, libgpio-tools. These are the tools that I was talking about. So let's first use the GPIO info, GPIO info. So these are all the GPIO that are connected to the main core of the CPU. So all the pins and offset are provided here. So we can use GPIO detect. So it said that the GPIO chip 0 is only available. That's cool. And then we have to use GPIO set. Oh, let's open up my camera. GPIO and set GPIO set to 1. Set GPIO set. First, we have to specify which chip that we are using, and then we have to specify the pin number. So remember that 32 plus 4 PB4 GPIO set -- help. So first we have to specify the chip name, offset, and then value. Okay. Equal to 1. Okay, it's turned on. Equal to 0. Turn off. On. Off. Okay, here it actually we are using some GPIO tools to connect to the GPIO and turning on and turning off. So it's time to write a C program. I mean, would you like C or Python? C would be better. So we will write a C program to access this GPIO and have some fun and some blinking LED. So let's power it off, power off. So to do that, we need to create a new recipe for that. Okay. This time I'm gonna be wise and add the layer to the BB layers first. Okay. What was the name? We can use meta Shaheen. Save this one. Remember from the previous time, we have to add a meta layer that we want under the Poki. I call it meta Shaheen. And under here, we have to create a new folder, state recipe - support tools. That would be better. I mean, it's up to you. And then here you have to create another folder, name the project that you want to use. I call it my GPIO. And on here you have to create a folder named file, create that. And here we have to add, let's open up a new terminal. So nano my GPIO - underline the recipe name, the recipe version. Let's say 0.00.bitbake.bb. So under the recipe, we have to add some information, such as summary, if you would like. This is a C program for linking an LED on RISC-V. You can say description as well. In my description, license is also important, because we don't have any license, we can use closed, or if you have any license, MIT, GPIO, GPL3 too, you can add that here. Then we have a source file, URI, and the source file should be placed inside this files. Let's call it file my GPIO.c. I will create this my GPIO.c later. So the S parameter would be the working directory. Oops. And then we have do compile. Do compile. For how we are going to compile something in here, using this GCC, we can use CC parameters and then my GPIO.c file, and then the output file would be my GPIO as well. And then do install. Right now we just compile it, then we have to install it. Do underline install. So we have to use install -d. So where should we install? Under the working directory. So under the destination, and then binary bin directory would be okay. Bin dir. I mean, you can use whatever subdirectory that would you like, and then install -m my GPIO, the output of this file, and then the same address. Copy and paste. Yeah, that should be everything for the. I used the wrong. Okay, I will save this file. So the next step, I have to create some C file. Go to the files, and then nano my GPIO.c file. So what you need, you have to sharp include, same as always, stdio.h, sharp include, because we are using the GPIO, we have to use GPIO d.h, and then void main, void okay, and then here you need, that would be useful if you go to the internet and search for GPIO d.h, so, and read the documentation. Otherwise you can just follow my instruction. That would be quite easy, because we have to just set the direction and then set some value, and then we have to use the some delay. Okay, so what we need, there's a method named GPIO underline chip underline open underline by name. Okay, here the chip name, remember from before, GPIO chip 0 was available, so let's put it into some variable chip. I will define the chip later. And then we have another variable LED, and it should be equal to GPIO underline chip underline get underline line. Which line we are using? GPIO PB4, which is 36. And then before that, we have to specify the chip as well. And then we have to say GPIOD. Probably I did some mistake. GPIOD, underline line, underline request, underline output, because we want to make this GPIO as an output. So LED, the structure that we assign to the line that or pin that we are going to use, and then you have to specify a name. I can use Shahim SV, and then what is the default value for that? It's 0, and you can just easily use GPIO d underline line underline set underline value, LED underline 1. You can easily assign 1 into that. So the value of this pin would be 1. You can set it to the 0 as well. Paste 0 as well. So right now we have to specify these LED and chip structures. So these are two structures. Struct GPIO underline chip. We have to make it as a pointer chip, and a struct GPIOD underline line, and then the LED pin name. Okay, that would be everything. I mean, let's make a while here, while 1, because we are going to make a blinking LED, and we have to add microsecond sleep. 250 millisecond, 1, 2, 3. You sleep 250, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So Control X, Y. It is saved on here, so everything should be ready. After that, we have to say the Yocto project to read this file as well. So at the end of this image install append, we have to say GPIO, my GPIO as well, my GPIO. So in that case, the Yocto project include this recipe as well. But before compiling the whole Linux, just let me just compile this my GPIO. So to do that, I have to just specify, instead of saying the core image minimal, I have to just say my GPIO. That would be everything. I hit enter. So there's a problem here. Work directory, there's no I in here. So let's run it one more time. So there's another error. So it couldn't find the GPIOD. I mean, it's fair, because how the Yocto knows which library should be added here. So first we have to say depends is equal to libgpiod. So it said that before running this recipe, this package should be compiled and be available, and then we have to link it into this compilation as well, -l link GPIOD. So that should be fine. Sometimes it is really useful to compile the codes one by one instead of just compiling the whole package of the kernel at the same time. So you can debug it much more easier. So didn't find LD flag. It said that it doesn't pass the GNU hash, didn't pass the LD flag. So we will add the LD flag, no problem. Target underline CC underline architecture plus equal to LD flag. $LD flags. Hopefully this time will work. I get so tired. Okay, hopefully this time is working. And now we have to compile the whole image. Okay, it's done. I have to add the SD card to the PC, virtual machine, clean the disk. Delete. And start copying. Okay, it's done. Connect it to my board. And hover on. Let's bring down everything. Root. So our file was my GPIOs, and it should be under the user bin. Let's just search it out. Dash name my GPIO. Yeah, under the user, under the bin. And if I run this program, let's open up the camera as well. And here is a moment of truth. Yeah, it's working as expected. That was everything that I would like to add to this video. So don't forget to hit the like button and subscribe my channel. And thank you very much.